This is the solution video of AS level mechanics 1 question paper 42, which was written in the first week of May 2021. Here, they say there is an object which is being dropped down, which means U is 0 for it. There is another object which is thrown up, projected upwards at 30 meters per second. Okay, they collided somewhere here. And then coalesce. They became one. After that, together they formed a particle seed. That seed dropped, hit the ground. Okay? Now there are two conditions. Once this object B is twice the mass of object A. Second case, object A is twice the mass of object B, and that created confusion among the students. So, we will talk about the masses later because when we use kinematic equations, masses are insignificant in kinematics equations. So, we will just focus on the time when they collide and the distance they travel. Okay? And we are especially interested in this distance because they will drop from here, from this point of collision. So we will take this as x. That means because the total height is 15 meters, so the remaining height will be 15 minus x. Okay, so let's make different equations for them. So I'm making one from the one object B. Okay, it will be S equal to UT plus half AT squared. S is 15 minus x for object B. U is 0, so UT will be 0 plus half A is 10 and T squared. Because this distance is downwards, acceleration downwards, both are positive. This is very important to know. 15 minus x will be 10 and 5 cancel out, 5t squared. Okay? Now let's make a similar equation for object A, which was directed upwards. So x is the distance it traveled before colliding, equal to u, which is 30, t, then plus half, but this time the distance, the direction of x and the acceleration are in opposite directions, so it will be minus t squared. So x becomes 30t minus 5, again this cancels, 5t squared. Now let's plug this value of x into the equation we got for object B. So it will be 15 minus 30t minus 5t squared equal to 5t squared, which comes out to 15 minus 30t plus 5t squared equal to 5t squared. Both are 5t squared, so cancel out. Okay, so what is that? 15 minus 30t equals 0, and 15 equal to 30t. That gives us t equal to 0.5 seconds. That means they are colliding with each other after 0.5 seconds. Let's find out what is the distance traveled by the object A to collide with object B. Since we have assumed it to be x, so let's write x equal to ut. U is 30, t now is known to 0.5, and then minus 5t squared. Yeah. So x equal to 15 minus 5 times 0.25 into 1.25. Okay, that comes out 13.75 meters. This is the height from the ground where they collided. So now we have to find out how much time will C take. C is the combination of the two objects to reach here, to the ground over 13.75 meters. Okay, for second part of the question, we need some more space, so I have cleaned it. So now, because they are colliding, we will use conservation of momentum. All right, so it will be m1 v1 u1 plus m2 u2 equal to m1 plus m2 v. Yeah, because they gave one body, so we will use this one. So, do we know u1 when they collided? No. So let's find it. So we know that B was dropped and A was lost, right? Here the U was 30 and here U was 0. They met after 0.5 seconds, right? So we can find what was their velocity just before colliding. So let's call it V1, not U1 right now, it will become U1 later. Equal to 0 plus 80, right? A is 10, T is 0.5. That becomes 5 meters per second. V2 will be 30 U plus, because it's decelerating, and 0.5, which becomes 25 meters per second. Now, we will use conservation here. So, first situation when B is heavier. So, let's say B is 2m, A is m. Okay. So, for B, the U1 is 5 meters per second. So, we'll write 2m times 5 plus m2. M2 is just m times the velocity of A is 25 meters per second upwards. So we will not write positive this one, we write negative. Because it is upwards. 5 meters was downwards. So be upwards. Equal to total their masses are 3m and B. Since we have same m in all, we will cancel m from all sides. So m is irrelevant now. So we will write 10, which is 2 times 5n minus 25 equal to 3b minus 15 equal to 3b. B becomes minus 15 over 3, which is minus 5 meters per second. So positive, I took positive downwards and negative upwards. That means the final velocity, they will go upwards with 5 meters per second after collision. Okay? And now we know the height is 13.75 meters, right? So this is the final equation. Their masses are 3m. Their velocity is minus 5 meters per second upwards. Okay? Distance they have to cover, displacement rather. Distance is, they will go upwards and turn back and then come down. But we'll take displacement. It is 13.75 meters. Mass is irrelevant, but I have written it here. So let's find what is the time they will take to reach the ground. So we will use S equal to UT plus half AT square again. S is 13.75 downwards, right? So we're taking it positive. All right. U is 5 meters per second upwards. Time is unknown, plus half. Because distance is downwards, acceleration is also downwards, positive, t square. So that comes up with 30.75 equal to minus 5t, this also cancels, plus 5t square. We get a quadratic here, which will be 5t square minus 5t minus 30.75 equal to 0. So using our calculator, the time one I get is 2.232 and minus 1.232. For obvious reasons, we will not accept this one. So we got one of our times which they are asking us to compare finally. So same activity we'll do now when the lower object A is heavier. So what changes will come? This 2m will become n, this m will become 2m. So let me change that. So this will become n, this will become 2m. Okay, and let's read the calculations. Okay, so it becomes 5, again n, and n will get cancelled out. So 5 minus 50 equal to 3. Yeah. So minus 45 equal to 3b. That gives us b equal to minus 50 meters per second. In this case, the object will go up by 50 meters per second. Earlier it was 5 meters per second. So we will make changes in our rest of the calculation as well, which is here. This and this will not change, right? Because it was before collision. So what will change is this now. In place of minus 5 to minus 50, right? The distance is still 13.75. Acceleration is still 10. So that will change here. So minus 15t will be here. So 5t squared minus 15t, and now our times will change. I'll write that t2 here now. So t2 came out to be the positive one, 3.376, which is obviously more because it went up with minus 50 meters per second upwards, so it took more time. So difference between times now is easier to find. 3.376 minus 2.232, and this 4, yeah, 1 and 1. So question, if they ask 1 second, 2 second, I don't know what time they take, but this is what our final answer is usually round out.